Hello. Yeah, very good morning and warm welcome to everyone. My name is Rana R.K. Singh. Uh, we are waiting Mr. Director Mr. Kanan, sir. He will be joined shortly. So just to begin with, today we are going to discuss very important topic, which is planning norms and design benchmark indicators for the water supply scheme. If you
Good
talk
morning.
about
Sorry,
good,
good morning. I've already joined. I'm part of the
oh, you have
webinar.
joined. Okay, thank you, sir. So would you like to say a few words,
Please,
sir?
please go ahead. I'll pitch in between.
Thank you, sir. So, sir, if you talk about the project life cycle, where we have the planning, design, construction, operation, maintenance, and you all will agree with me that planning and design is one of the most very important and critical aspects, right? So, our objective of water supply design that we should get safe drinking water in adequate quantity, which is 55 LPCD at the consumer end. Our network should be equitable pressure so that even after the tail end, consumer get the adequate pressure. The water supply should be reliable and should be affordable. Whatever system we are designing, that should be the very cost optimum, whether we talk about the capital cost, operation cost, and most important thing that the system is reliable and the sustainable for long period. And to meet all these objectives, we require very meticulous planning and the sound engineering practice. So, to deliver these aspects, key aspects of the design aspects, with me we have our prominent speaker, Mr. Hingorani. Mr. Hingorani is retired chief engineer from Chhattisgarh PHED department, and he has a very vast experience in water and sanitation sector, more than 49 years experience. He has been also task force member of our Jal Jeevan Mission, and currently he is also the key training experts for WAS area. So, with very brief introduction, I would like to hand over session to Mr. Hingorani to start the session. The session will be around about 1.5 hours, and the technical presentation will be followed by the question and answer session. But if you have any questions, we request you all kindly to put in your chat box also. And my humble request is to switch off your microphone unless until you want to speak something. So thank you very much once again. And Mr. Hingorani, sir, over to you, sir. Thank you.
Namaskar. Good morning, everybody. Namaskar. As Mr. Rana has told that I am going to present, this is the basics of the water supply scheme today. The PH engineer or KRCs or ISS or NGOs or consultant, basically who are involved in the planning and designing of water supply scheme. So what I'm talking, the key is a planning designing. If you might have gone through the VAP, Village Action Plan guidelines of the Jal Jeevan Mission, basically, ultimately, Village Action Plan suggests the things how to plan a Village Action Plan and planning and designing a water supply scheme guided by Village Action Plan. But here, technical inputs are required, referring to planning a design period. And secondly, what the VAP suggests that design benchmark indicators are to be basically governed by the CPHO manual. I am not taking much part. I'm going to share my presentation. Okay.
Join now.
Yes, I would like to actually, you can go ahead formally welcome you all to this webinar, and I am also grateful to Hingorani Saab for he has been, very enthusiastic. He has always been talking to me that yes, I would like to, share my experience. I always think that people who are retired are great assets to this nation. Their resources, their knowledge, their experience, their wisdom should be utilized for the larger good of this nation and larger good of the public. So I am really, really grateful to Hingorani ji for coming forward for this session. And I would also like to share you that we have planned that on every weekend, probably, preferably this Saturdays at your convenient time, we'll have this kind of discussion where people, engineers, and other other stakeholders of JJM can come forward, share their experience. So this is a kind of, I think, thanks to the information technology which has enabled, this has been great enabler. So you can always listen while someone is traveling, you can listen this, while someone is in the field, he can listen, while someone is sitting in his comfort of his home, he can listen. So I think this is a very good thing that we would like to continue this. So I would also like you can always, we have the mail ID, NRCJJM, so you can, if you are interested to share your experience, share your wisdom, share your field experience with the larger audience, you are most welcome. So I once again thank Mr. Hingorani for this great initiative, because he is the first person, maybe I think at least this episode. So he has been the first person to take forward. So I am again very grateful to him, because he has been so enthusiastic, so committed. I really appreciate his commitment, his sincerity, and coming forward for sharing his rich knowledge, experience that he has gained over maybe more than 3 decades of his field experience. Thank you so much once again, and I again welcome you all. And thank you for your great support. I see around 200 participants have already joined this webinar. It's very heartening to see such huge participation. Thank you so much. Thank you so much.
Thank you, Kanan Saab. Hello, I am audible.
Very much audible.
Yeah, thank you. So basically, in the top of the screen, you see that basically I am going to talk on 2 issues. One is planning norms that suggest a planning and design period basically for the water supply schemes. And secondly, I am going to talk at design benchmark indicators as conceived in CPHO manual and practical experience we will suggest here. Thank you. I will proceed further. So see the goal. I am not going to take a basically goal itself have a benchmark indicators for adequate minimum 50 piles PCD, prescribed water quality again BIS 150, and regularity and sustainability of FSDC as talked upon. In all time, all situations, this is aided as per NRWB guidelines. So I am talking of water security and sustainability at affordable service delivery charges through functional house tap connection over the design period. So these are the basically the guideline itself conceives the benchmark indicator in one para. You see the here. So basically vision that you can see the what the goal suggests that it is a triple S principle, sustainable rural water supply
ये
scheme.
नेटवर्क नहीं चल रहा हो चालू ही नहीं चल ही नहीं रहा
Hello. Hello. Hello.
You please go ahead. You are very much audible.
Yeah. Sustainable rural water
Request
supply.
all other participants to kindly mute their mics, except the speaker.
So basically, sustainable water supply. Basically, we are talking of services here, but at scale. Scale is you can say 50 miles CD or again drinking water quality parameter. So basically, by definition, it is a triple S principle. So basically, the present object of the present to define the norms and benchmark indicators for planning and design of water supply under JJM. In consideration with a techno-economic, what Rana says, I need a least capex cost and minimal opex that should be affordable by the community. It has been defined in the guidelines. This is kept in mind. So I will talk on later that what the things are happening in the states. Ultimately, aim as Jal Jeevan Mission is make a water everybody's business. Okay. Jal Jeevan Mission program any says that village water supply scheme is to be planned, very clear, planned implemented, managed, and operated by local panchayat Raj institution mandatorily under 73rd, 74th Amendment, Constitutional Amendment, for the community, by the community in sustainable manner. This is the key requirement of JJ. Keep it in mind. So things are very clear that scheme involvement of the community is a major, is going to play a major role, which should be taken care of. So ultimately, what the mission, JJ suggests the mission, Jal Jeevan Mission, will provide a massive lift to the ease of living of the women with a reduction in drudgery of the walking of miles faced together. JJ aims for the eradication of waterborne disease too. This is the major role of the JJ going to play by providing household tech connection for every person in houses. So if you go through the goal, so I had defined exactly what are the benchmark indicator for the FSTC, right? Water quantity, minimum 55 LPCD. We will discuss on that. Source, here key is we need 100% dependable source. It is one of the foremost requirement. Water quality of drinking water should be as per BIS 1050. Again, same things has been produced on page number 41 of JJM guideline. Again, extent of unaccounted water has been considered less than 10 to 15, maximum is 15%. Try to keep it less than 10% in the smaller water supplies. Basically, we do not go, but 15% is water. We can think of the MBA system. Pressure requirement as considered in JJM guideline, minimum 7 meter in household premise at payroll point. Keep it in mind. Again, coverage of FSTC has decided 100%. That too added all the institutions covered in the villages, Anganwadis, school, PHC, Panchayat Bhavan, community center, ashram, also there are to be covered. Coverage should be 100% at the end of the completion of the scheme. In village O&M by Gram Panchayat, VWC or Pani Samiti or any local institution. In village O&M cost should be affordable. Here rather I am talking that O&M cost is in village O&M cost is required to be made through the revenue generation. FSTC is required functional and regulator. So here we require an appropriate monitoring system to ensure that my functional house step connection is providing appropriate water, proper quality over the design period. I'm putting a word here, over the design period, not for the moment. So further, if you can see, first of all, I need to have identification of approved water supply scheme with a community partnership. I will take up a single village, maybe a solar scheme, maybe your multi-village scheme, maybe a retrofitting, maybe augmentation. What thing is required? It has to be identified, sitting with the community during the VAP, right? So secondly, what the JJM guideline conceive, for the such a scheme, once a scheme is decided, during the discussion with the community and technical input is given by the ISA or the whosoever be acting as a nodal officer for the technical support. So source idea, sustainable source is the most important issue play in the planning. So their next step will be Deepu, Anant.
We can't see the presentation, sir.
एक मिनट.
Sure.
Yeah, sure.
Okay. Now it is coming.
No, not it, sir.
No, sir.
शेयर कर दो ना. नहीं है.
Maybe you can log out, then come in.
Yeah, I'll come. Yeah, surely, sir. Is it coming?
Yes, it's coming. Yes, we are able to see. Thank you.
Yeah.
Okay, thank you. So again, The third part is planning, designing, implementation of water supply scheme in discussion with the community. Right? Here, handouts will be provided by the ISAR technical agency. Fourth, it is affordable, because once you are conceiving your scheme, that should be in consideration with affordability of O&M. This is one of the major things which is required by the JJ. Then regulatory FSC. Ultimately, if I sum up the 1, 2, 3, 4, I need a regularity of the FSTC over the design period. So system sustainability, ultimately, I have to achieve. With that background, what I talk, JJM consider it is a VAP. The decision making will be the village action plan to be developed by the department for each village in collaboration with the VWSC, Pani Samiti, community, user groups, and this is the process which is defined in the JJM kind. I need to have the baseline survey and mapping first. Then what the JJM requires, basically a sustainability, I need a IEC and capacity building of the various stakeholders, communities, even ISAs, even technical. I need not an engineer, I need a social engineer here. Here, engineering cadre is going to play a major role, especially junior and assistant engineers, which are the know-how, the technical, but they should have communication skill basically to communicate with the community and PRIs also. So ultimately, I go for the source sustainability. Then based on the sustainability of sources, I need a protected water supply and FSTC. Further, it has been considered that grey water management will be the part of the JJM. And ultimately, it is a sustainable O&M. And finally, assessment of functional assessment. So we will be talking in the some next topics discussions regarding IoT for monitoring, which will be giving the whether my functional assessment of FSTC, how to be possible. So ITA planning, design, village water supply is part of the village action plan, right? So coming back to this design period is number of years basically. In the future of your given facility available to meet the required water demands. So water demands, whatever the design period is there, okay? For the rural water supply, planning and design period can be 15 to 30 years in consideration with the category scheme.
अब आ गया आवाज वो इंटरनेट से पहले बनता है इसका देखा था मैंने तो
Hello. So for the rural water supply, planning design period can be 15 to 30 years in consideration with the category scheme, type of source, technical feasibility, in consider life cycle concept, but CPHO manual and JJM guidance suggest technically it should be 30 years until unless for sustainability is issue. Please mic your phones. Mute your phones. The scheme shall be planned and implemented to have minimal capex and optimal opex in consideration of life cycle that is called a design period. नहीं चल रहा है यार क्या तमाशा तुम्हारा.
Yes, Hingorani sir, it's available. You are visible. Your PPT is visible and you are audible also. Please go ahead. Perfectly fine.
Yeah. So, as already discussed, this JJM guidelines suggest single village scheme, solar-based mini pipe water supply scheme, multi-village water supply scheme. Scheme number 1 and 3 can be either on groundwater source or surface water source. And practically for solar-based mini water supply scheme, it is presumed that these schemes should be based on the solar-based system, because maybe having population of 2,200, 250 or 300 or so. So this picture is depicted for the single well scheme. Tube well is there, tank is there, and houses are there, consisting of source, pump, tank, chlorine dosing system, pipeline, house connection, etc. Secondly, this is a mini power supply scheme. Here it consists of tube well, pump, solar panel, storage tank, treatment unit if required, just like in case of fluoride affected, iron affected, we can think of some standalone treatment system, distribution system, and FSDC and washing platform too. So this is a depiction of the multi-layer water supply system. There is a surface source, master reservoir, pipeline, conveyance, and complete layout of system is there. So again, it is a schematic diagram as required in the CPHED to be planned. So planning and design period basically is governed by rate of growth of population. This is one of the most important factor. Various water demands as defined in the JJM guideline. Lag period will be coming as defined in the JJM guidelines, but subject to it should be minimized for the performance time. Again, availability of funds. Interest rate if some borrowings are taking place. Economy of scale. Ease or difficulty of extension for the future water supply scheme. Life of the structure, which we'll be defining here. Quality of material is going to be a major role. Type of source, ground or surface. This is going to be decide the planning and design period. Again, topography. Ease or difficulty in maintenance. Most of things are mentioned in the CPHO manual. So if you go through see the table here, as per JJM guideline, there are 3 types of SVAs: solar mini power supply scheme, single multi-layer based on surface source. So as defined source, I will be discussing because in the single or multi-village water supply based on surface source, all the data has been discussed as per given CPHO manual. In the SVS MBS, I am going to discuss on the source, where groundwater may be a tube well, dug well, or a spring source. If my groundwater source is sustainable, just like in Bihar Gangetic Plains, in Uttar Pradesh, some Ganges where alluvium strata is available, I can think for going for the 30 years planning design as suggested in the CPHO manual. But in case, just like Madhya Pradesh, western part, Maharashtra, where arid and semi-arid zone are occurring, where tube well sustainability issue, we can, again, it is a site-specific decision to be taken, whether is it, I don't know, 20 years, we can think of that. But practically, decision should be even in conjunction, you can see the water supply scheme in the Gujarat are being designed in conjunction the dual water sources. So we can prefer to go for 30 years until unless if it is not available to such sources are there, we can think of the groundwater sources 20 years. Accordingly, all the components has been planned in provision of CPHO manual. This is depicted here. So one addition is coming over here, solar panels, which is not given the CPHO manual. Basically, solar panels life has been suggested almost 20 plus years. So based on the solar panel life, if I am going for the retrofitting of the existing single well water supply scheme, so think that solar panel can withstand for 20 years, no problem, because if I am putting a groundwater source, this is against mini power scheme, there's no problem. We can think of 20 years. If I am putting a single multi-village surface water supply scheme, this is going to a major role, because a lot of questions were coming to me in earlier discussions, whether it is feasible for the yes. I will talk in the later on this issue. Again, all the things as given in the CPHML has been defined and I will discuss on the bottom what these are tanks as suggested in CPHO manual. Only solar has been considered accordingly. Number one, I suggested that if required in standalone system can be defluoridation system or iron removal if required. Then I suggested a hash system. A sphere design period based on the groundwater has been considered with respect to life of the source as per manual preparation of detailed project report. It was suggested earlier, but I already discussed that if my groundwater source is sustainable, we should adopt it 30 year. If source is sustainable, then design period should be taken as per CPHO manual. And thirdly,
I'm sorry for interrupting. I would like to request the participants, if you have any doubt, you can put in the chat box. Finally, I think we can discuss that. Please, if you have any doubts, if you feel that you may forget till the last, you can put it in the chat box. At the end, we can, discuss about those. The speaker can, see those doubts, maybe your views, and then it can be discussed at the last. Yes, please continue. Thank you.
Thank you. Thirdly, already I have discussed the solar mini power has been decided in consideration with the solar panel cost, solar panel life. So again, the lag period should be decided in consideration with the page number 30 and 7.5 to the operational guideline of JJM, which is depicted here. So basically, this has been as considered the JJM guideline, but now this guidelines were issued about 2 years back, almost. So I put a note: lag period can be further minimized with appropriate planning in consideration timelines with a JJM. Because now we have to complete the scheme by 2024, so you can minimize the execution, planning, execution lag period, you can say. So other thing coming, pumping hours play a key role in planning and design all water supply scheme. Higher the pumping hours, lower the project cost. Being a rural water supply scheme, pumping hours can be adapted. For single grid pumping hours can be considered 20, but in no case should be 16, subject to the power availability in the grid. Solar-based water pumping scheme, pumping hours can be considered as a minimum peak sunshine hour of the location. And for the multi-village water supply scheme, can be considered 22 as per CPHO manual. But in any case, consider the maintenance, operation, and backward should not be less than 20 subject to power availability. So I put an example. If my base year is 2021, mini water supply scheme is required to be completed in 12 months. Then groundwater based single source should be completed 16 months. But prefer should be given, should be completed in the 12 months. Then, so accordingly, I have given the one picture that how the planning and designing stages are required to be covered. Accordingly, my all components are required to be designed. So second issue comes up the identification of the project area, which is key. The proposed project planning area of habitation, village, should be clearly identified and demarcated on georeference map. Map should be prepared showing topographical and other features. Okay, and whether what is its administrative and political jurisdiction, is a Vidhan Sabha area or anything as well, should be clearly defined. And this has been communicated in the para 2 of CPHO manual. This is based on this is the key requirement of the CPHO manual. So I have defined two types of system, single phase scheme, and in the single phase scheme I have shown the habitation, and this is a multi-phase system, how the plan project has to be defined based on that. Now, as suggested, once I defined the project area, the estimation of future population of various phases of the proposed water supply scheme can be carried out for different development matter as suggested in CPHML. So, based on the actual methods, it is a designer judgment practically what the estimated population of various stages should be there. However, as suggested, decadal growth rate at 2011 or growth as suggested in JJM guideline is to be considered for future planning and should be adopted for the planning purpose. So these are the water supply needs, okay? Domestic as defined in 55 liters in all the conditions. Personal hygiene and hand washing, we have considered 5%, but based on local judgment, you can consider lesser than that. Okay. For the institution, as suggested in JJM guideline, PHC, community, all the thing, we have considered 10, but this is for the example only, but should be based on the local judgment. You can reduce it as per subject to the source availability and requirement. So total of 1, 2, 3, that what he has a personal hygiene is to others, coming out to roughly 63. That is unaccounted water. For the single village, I suggest should be taken as a 10%, MBS should be 15%. Accordingly, this water demand has been considered. And in case of the surface of water supply scheme, we need to consider 5% of the filter backwash. So see here total maximum allowable water demands has been displayed for SVS based on groundwater source, mini pipe water supply scheme, and multi-village water supply scheme based on the surface source. So this is the maximum allowable we have decided and should can be further optimized or minimized as per site specific requirements. Other issue mostly in the Rajasthan, Gujarat, other places coming, livestock water demand. So what the guidelines suggest that especially hilly terrain data for what we are talking need to accommodate the livestock water demand. Okay, there can be a standalone system utilize local sources to meet the livestock. If other sources are available in the village, just like ponds, etc., dugways, try to have a utilization of that. Until unless necessary, the cattle water demand can be considered as per in the project report, but subject to the decision of the local state governments.
Okay, madam.
State is free to plan design more than 55 LPCD. Keep it in mind. However, additional funds required for the execution for more than 50 LPCD shall be made from the state government budget. Very clear. Number of states are planning the system 100 LPCD, 150 LPCD. It is clearly categorically JJM guidance suggests that funding provision for the JJM schemes shall be limited to 55 LPCD. Describing the so other part is required as per CPHM manual. You have to go for the mapping of the existing water supply component, which mostly state does not consider. Most of the state goes for the new scheme. This is not required. So you prepare a existing water supply system plan. Okay, what are the components, and have a put one source. Example, I'm putting SVS source, then conveyance, then treatment if there, then storage, MPR, distribution, status FSTC should be properly mapped. And further, I will discuss with you, once you have mapped your existing water supply scheme, what are the basically gaps and shortcomings with reference to benchmark indicators, which will provide decision making, what is to be done, what is not to be done. So, year of commissioner scheme is required. I have seen lot of schemes which suggest just about scheme as commissioned 2 years back. They said we need a argumentation. I agree with the profiting, but not for the argumentation. If argumentation is specified the details component wise, present function states are each water supply component. It is very. If my pump is okay, which is commissioned 2 years, why I need to replace the pump? If my source is sufficient, why I go for the additional sources? If my source is not sufficient, only I need to develop some additional source or support the additional source system. Assessment or utilization has to be decided properly. Coverage of pipe network and FH is very clearly defined. Whether village is covered the network fully or need addition. Again, how many FHTCs are there? So this can be part of retrofitting. And assessment of aquatic water and adoption minimizer practice is required very much. Present water supply remain should indicate the existing population, household with FHTC, physical distribution, as other features like health issues. It is most important because we are talking of protected white supplies, pipe supply is providing. Ultimately, aim is to minimize the waterborne disease and quality of services, which is most important. Okay, because we are trying to say costing from the revenue of the water supply scheme. So we have to provide the quality of services to the community, which is most important point. And ultimately, this quality of service will be required for the willingness to pay from the community for the services we are going to provide in the project. Based on the above calculation, what I suggest is point out the deficiency, gaps, if any, water quality, quantity, delivery system in accordance with provision of the planning norms or design benchmark indicators. As we will decide further, this has been suggested in the CPHO manual. So there can be a 4 type of scheme. One can be a retrofitting. Basically, retrofitting is defined as a, you can say, improve the efficiency of the system. Okay. Rejuvenation and restoration, other part of the scheme. Say my pump is not functioning, so I need to rejuvenate the pump. Restoration, my pipeline is totally not functioning for low. So I mean, my system is, if I am restored the pipeline, my system is functioning nicely. Augmentation, if my earlier system is already completed life or going to complete life, and new scheme where no already pipe system is there. So this is a part 1 where we are talking about the benchmark indicators or planning norms and guidelines. So we'll be talking about benchmark, design benchmark, which is key for the designing. I'm repeating this slide. I had to design either ACS or mini pipe or MBS. Type of source can be groundwater, surface water, impound and reservoir. So 3 types of sources are there. Design period, already we have discussed, as per CPHED should be preferably kept as a 30 years. And for the component right, as should be decided in the current provision of CPHO manual. Most our state does not follow these things, which I have observed. So source should be identified, which shall be, first is the capable of providing required quantity of water for the design period, say 30 years, as case may be, with the 100% dependability. Here, drinking water required a 100% dependable source. right? Second part, I am coming to groundwater-based sources. Source should be capable of providing required quantity of water for the design period, meet the ultimate water demands, as the case may be with the 100 was supported by the data. Yield test, etc., drawdown, everybody is required. Drinking water security and sustainability scheme may have more than, this is a new suggestion coming based on case studies. For the drinking water security sustainability scheme, we may have more than one source. This is for the drinking water security as conceived in the NRWB guideline. Quality of drinking water sources shall be tested in accordance with 1050. If it is not there, what the treatment is required should be decided upon. Intake structures, basically in number of schemes I have seen is intake structure holding capacity is are even adapted even 1 hour, but as per design guidelines should not be more than 10 to 20 minutes maximum. Appropriate inlet ports should be provided along with the gantry arrangements, and is space in the pump share करो, share करो. Space in the pump house shall be capable of housing 4 or more pumps as per design consideration for future expansion and optimal utilization energy efficiency of the pumps also. Minimum 4 pumps are more suitable for operation maintenance with a 50% additional. So CPH will clearly suggest that standby systems should be 50% should be provided. Selection of pumps should be governed by the requirement of water quantity, including filter backpass for raw water. So what we have seen that clear and raw water pumps quantity is being adapted same. It is not practically correct thing. For the raw water, we have to consider the inclusion of backward washer to be provided in the filtration system. Then we need an exact static head and other heads to be considered for the design from the ball assembly, and other losses are required to be considered 10 to 15%, which are on account of walls, fittings, etc. based on the site-specific conditions. Provision should be made for on account of power losses in the thrust bearing and line shaft bearing as 3 kilowatt, also 10% margin of the power losses in motor need to be considered as per CPHO manual. It has practically seen in the designs in some states that this para is not considered while planning and designing of the pumping system, or in few states, higher margin is considered even 15 to 20%. This is not also desirable. So operation of pumps shall be planned to ensure optimization of energy costs in considered water requirement. But here I am talking mostly if I am designing a pump for the 15-year water demand, say 100 MLD, okay? And my present demand is roughly 70 MLD. But most of the practices that right from the beginning, 100 MLD is being pumped water, and we are giving more water. So by if we prepare one graph or trend system for every year, what is the present demand for every present demand based on how much pumping hours required. So this will be optimization of energy also. Possibility is there. So to ensure the minimization of energy costs, preference should be given for the solar water pumping system. System can be either standalone or grid can be considered as per requirement. What I am talking, this is a study suggests that most of the you say surface water supply, regional water supply, multi water supply are having huge OPEX cost. Even cost of production of water is going around about 15 rupees per kiloliter. And you see, power cost is roughly 60 to 65%. Cost of the cost of production of water can be truncated even one third if providing the solar system. One suggestion is more is there extension of high tension power line 11 kVA grid preferably dedicated for will required, especially in multi-watt supply scheme where we need 100% transformer capacity arrangement standby system. This has been conceived in the CPHO manual. Transmission of raw and clear water, economical size of pumping main shall be designed in accordance with the requirement of the design periods as specified for the surface groundwater source with the help of computer modeling as suggested in CPHO manual Appendix 6.7. Selection of pipe material shall be governed by maximum operating pressure as per requirement of guidelines, including surge pressure, quality of pipe material, in consider site-specific needs and life cost approach. I will give you, I will put some case studies, what I am talking here. Design velocity should not be less than 0.6 meter with a minimum water demand to avoid the deposition of corrosion. And secondly, if you are putting a lower velocity, may increase your diameters, which is capital cost is going very high. Technically, if you go for the economical size, on an average, for the medium scheme up to medium schemes, most economic can be worked out with a 1 meter velocity or even more. Pipe material for pumping main specifically, what I am talking, recommended metallic pipes with inner lining. Unlined pipe material should be discouraged as conceived in the CPHO manual because unlined pipes are having C value quite on lower side. I am putting example, DI line K9, K7 or inlined outcoated MS pipe or other suitable pipe can be considered subject to the techno-economic feasibility, quality of pipe material, etc. and commercial availability too. So based on this, in the pumping mains, conveyance main, minimum internal diameter is required to be considered 80 mm, subject to the design. Water treatment, rapid as slow sand filter as per the cited decision. Okay. Accordingly, all the treatment systems are to be proposed. And further, if you have seen the planning design, WTP is to be designed in the phased manner with modular approach. And you can go for the civil work for the 30 years, but electromechanical works can be designed for the 15 years. Same is depicted here. Rate of filtration as suggested in CPHO manual. So one additional thing is coming, roughing filters, which is new, mostly new to the you people. In African countries and in Tamil Nadu, what I have seen there, because slow sand filters are susceptible to the turbidity very much. And with the time and space, turbidity is increasing filters, and these filters are being extensively used in the North Indian states. So to overcome the problem of the turbidity, roughing filters are going to act as a pre-filtration system very nicely. Clear water sum collection capacity has been given here 45 to 60 minutes. In some state, it is being huge collecting some are being provided 4-hour capacity, 5 or 8 hours capacity, which is not desirable. In water quality affected habitation, villages and appropriate suitable standalone system. Just I have shown you in my picture that where my population is 200, 300, I do not go for the surface water supply scheme where deflotation system, iron removal system, arsen system can be provided as per economical feasibility. In the multi-level water supply scheme, master balances are required to be prepared. Sound कर रहा है. Hello. So master vessels is to be provided, but here capacity is to be required for limited to 1 to 2 hours as per requirement. And advantage of MPR is required to create a master balancing gradation flow in the zone, and as per requirement of zones, we can think of number of master balancing reservoirs too. So basically, brake pressure tanks are required to be proposed in hilly terrains, most are things. And it has a capacity at 10 to 15 minutes only to reduce the pressure, and decision making how the pipeline is to be based on this. Approximately 50% capacity designed of water demand with a desired staging to ensure pressure. That is what we are talking in village for supplying 7 meter. And accordingly, earlier what I talked, appropriate zoning is required for the MPRs, vertical fitting, etc., based on the topography of the system. For the distribution system in village, we need to go for the peak factor 4. It is clearly suggested in para 10.8 CPHO manual for rural water supply scheme. Peak factor is required to be kept as a 4, not as a 3. 3 is proposed for the urban water supply scheme. This is a major problem. If you find that water is not reaching a fag end of the village, this is one of the reason. Tuning of water distribution can be ensured with the equitable pressure. Studies suggest that especially in hilly terrain area, this is a problem. Equitable due to non-equitable pressure with a higher hydraulic gradients, my tanks are not which are placed at a fag end or higher altitudes. So this is most important thing while planning the water supply distribution as well as the conveyance system through PANET. Again, minimal residual pressure as defined 7 meter. Okay, but try to keep us as suggested in guidelines, JJM guidelines, that on an average, this as per design may be 7, 8 or 9, but most of the states are considering 12, 15, 18, which is not desirable because I have to give the water in the premises of the household, not beyond that. Minimum internal diameter subject to design for the plain areas can be considered 63 mm. I clearly suggest 63 mm. In the CPH manual, it is 80 mm, but it is for the urban water supply scheme. Here we are planning for the in village, even for the habitational water supply scheme. So this is one of the cost optimization process. This has been adopted in Madhya Pradesh and running very nicely and successfully. For hilly terrain, it can be a 40 mm or so, subject to the design, because in the design we used to consider peak factor also. Pipe material. For the plain areas, we can think of the P grade 100, PN6 or any PVC pipe. Please try to mute. And DI pipe class A7 di-equal about 200 can be considered as per site specific needs. Not necessary. It is designed to see the water site condition. Again, for the hilly areas, GI pipe 32 to 65 can be considered. DI pipe class K7 to and above 80 can be considered, because in a hilly terrain, because it will be exposed to the surface pipe. So due to environment degradation and other things, metric pipe has been suggested. The Jal Jeevan Mission guideline suggests FHT, three number of FHT taps are provided in the FHTC. That is for kitchen, bathroom, outside toilet within the premises to ensure provisioning a safe and portable water. Suitable flow control devices to provide it. In this case, Andhra has a good device to control the water, and even if you provide a payroll and adapt it, adjust it properly, this can work functionally. But what we have seen in Andhra Pradesh, they have a good device to control the water supply level at household connection. For houses service connection, GI pipe or MDP pipe or UPS can be used, diameter 15 mm, preferable length 5 to 15, but subject to scientific requirement, maybe little less or more. Provision of washing and bathing places, kettle troughs, etc. can be considered as per needs. As conceived in JJ guide, it is a decision of the local community while planning the VAP. For the monitoring purpose, sensible remote monitoring system has been considered, especially for the in-village water supply scheme. I am categorically suggesting that in-village water supply scheme for the monitoring of the quantity, quality, operation of pumps, and especially monitoring of groundwater level. Key has been defined in the technical guidelines suggested by the Jal Jeevan Mission separately. So, in most of what we are seeing that people are switching over the huge SCADA, which is not desired in the guidelines. We need a GSM-based remote monitoring system for the monitoring of the in-village water supply scheme. Sustainability structure, planning and itinerary site study recharging structure like roof water harvesting can be considered. On the institutions, government institutions, surface water harvesting method, maybe trenching, contouring, bunding, velocity breakers, recharged small structures to support the in-village water supply sources. There is a feedback that we cannot take up such structure in the water supply scheme. I am very much talking of the in-village water supply supported by groundwater-based sources. And you can go for the financial support from the other institution, Manrega or any other funding agency. But this is one thing new is added here. Water consumption practices. In the multi water supply scheme, approximately 5% water we are keeping for the filter backwash. If recycling of that water is to be taken care of, you can have an additional 5% water. If I am having a water treatment plant 100 mld, so I can recycle back 5 mld additional water. So this is a recycling and conservation practice. Annual O&M, as defined in the CPHO manual and practices, O&M what are required to be planned in consideration. Staff wages is required, power bills are required, cost of chemicals mainly, regular maintenance of infrastructure, business expansion. So basically, O&M of inland water supply system is responsibility of the PRIs. And all the OPEX are required to be made through the revenue generation, very clearly. This is set to be kept in mind. So ultimately, while planning the scheme, OPEX is going to play a major role. So basically, these are the cost sharing system proposed in the JJM guidelines. In Himalayan and Northeast state, 90-10, 90 is central share, 10 is state share, others say 50-50. Union Territory 19-10, Union Territories without legislation 100%. But keep in mind, see the note, community will be contributing 5% of capital cost or 10% of the capital cost. So about sharing is governed by including this community contribution. Keep it in mind. So sharing, say my project cost is 100 rupees minus cost sharing minus cost of the community contribution, and sharing of that will be provided in the project. So I am coming back to one case study. I'm not mentioning any scheme name or so. This has been conceptual design of one of my case study. This is real time case study. So based on the case study, based on the benchmark indicators, we evaluated the things. Type of scheme is multi-village regional water supply scheme. Source is canal, no problem. Design period has been adopted at 30 years. Planning period should be in consideration lag period 2039-54, but this has been not done under the proposed project. Per capita water supply scheme has been considered 107.4 LPCD, which includes the urban water demands, which is not in line JJM guidelines, resulting in higher cost of the project. Design of water demand need to be updated because they are under technical stage. Pumping hours has been kept continuous, no problem. Source of water has been adopted as a canal, but no storage provision has been properly considered for the canal closure period, which is required for the regular maintenance. I think in the project it has been 1 or 2 days. The practical, which we have seen that canal closure used to take place more than 10 to 12 days even. So sustainability in this project, source sustainability issue. Assuming a diameter of canal intake, in the design it has been 1000 mm and velocity was at least 6 mm. We are gone for the economical diameter consideration with the velocity. Diameter could have been reduced to 7 to 750. It is a huge cost saving. In case of raw water storage is to be created, then the raw water sump is not required. Here see in the designs, Hessian billion has been considered 700. CPHO suggests 140 might be some
I have a question.
typing error. Raw water collective storage sump is to be designed to meet the water requirement of canal closure
I have
period.
a question.
Already 15 days on account of maintenance canal regular intervals. In gravity pipe intake and raw water rate of pumping has been considered for intermediate water demand for the pipeline design where it is required to be designed for the ultimate. So this is one additional issues. Diameter water pumping has assumed economic size of pumping needs to be worked out in accordance with the CPHO manual. And accordingly, suitable class of pipe is required to be adapted considering the pressure requirement. Raw water pumps multiplying factor is 50%, as suggested earlier, not more than 10% should be there. Pumping system combined efficiency has been 75%. Maybe it should be ensured that such efficiency pumps are available in the market. Accordingly, practice 70 to 75% combined pumping pumps are available. 75% seems to be high, but should be taken care of while designing the pumps. Pumping system designed for ultimate water demand, where the electromechanical equipments include pumping are required to design for interwater design as per CPHO manual. WTP has been proposed ultimate water demand, including electromechanical. WTP is required to be designed for the WTP electromechanical are required to be designed for the intermediate water demand, and as suggested, civil works are to be carried over for the ultimate. Clear water pumps has designed for the ultimate water. This is the same thing already discussed. Clear water pumps are to be designed for the flow exclusion filter backwash quantity. That has been not taken care of under the case study. Clear water sump capacity has been considered 3 hours, whereas it should not be, should be in between 45 to 60 minutes as per CPHO manual. Residual head in pump design cannot be 0. A partner design suggests velocity of less than 0.600 may be an issue of silt and deposit, as we had discussed earlier. Almost 50% network, which is not, it is in the almost 50% network of convincement. With the updation of velocity, diameter can be minimized to ensure cost optimization. A partner design suggests higher terminal pressure. With the minimization of diameter, terminal pressure can be brought down within the desired level, and equitable pressure can be maintained. With the inequal terminal pressure, at the time of operation of the system required, water quantity may not reach at lower terminal points, hence equitable pressure needs to be maintained. While designing the network in the PHED, pumping hours has been not considered, which may result in erroneous diameters in the present case study. While designing a network, a PHED, no consideration given for the other losses which may result in the erroneous diameter. So I can explain you. Say I am putting a pumping hours at 20. Accordingly, necessary correction has to be made in the PHED water demands. And similarly, other losses, a partner does not have any internal provision for considering the other losses. So the manual I partner suggests that clearly that you have to go for some adjustment in the factors. So again, issue of K7, K9 or MS pipe should be governed by the requirement of pressure. Operation and maintenance costs of such a scheme are very high over the design, which needs to be minimized. Recycle filter backwash, which we already suggested, should be taken care of. Hence, summary designs are not in consideration with the norms and guidelines of the CPHO manual, neither technically feasible or not financially viable, or the and overall sustainability of system is should be considered. Case study 2. Basically, in most of the cases, what we have seen is major water supply schemes are there and minor water supply there, and there in that state. Lack of source system in the proposed schemes is there. Water demands calculated are not meeting the ultimate water demand. Most of cases, slow sand filters has been proposed with the conventional pre-treatment system for surface-based water supply systems. Rainy season, reportedly turbidity is quite high in the sources. Proposed pre-treatment, that is sedimentation, is not capable of reducing turbidity as per requirement of SSF. Hence, under the circumstances, malfunctioning of SSF will take place. So already we have discussed on this issue. If you go through that, if we can introduce a HRF there, we can overcome the problem of the SSF. Case study 3. Selection of pipe material MS without inner lining outer die coating has been considered in the conventional, which is not desirable in CPHO manual. water supply level adopted as 100 LPCD. JJM guidelines suggest water supply level 50 LPCD. And other student needs, if we go for the, as we have seen that total water demand can be approximately 7 to 80 LPCD, not more than that. Even for the surface water supply scheme, 7 to 75 is sufficient. Per household cost of exceptionally high because of this hilly terrain, but exceptionally high. The JJM guidelines suggest 47,000 rupees per household. When in the such scheme, it is going approximately 1.5 to 2 lakhs per household. Require optimization. In the ideal project area, number of villages having number of functional existing single water supply schemes and commissioned few years back. So while planning the project area, we have to see how many schemes existing are functional, are working, are commissioned 2 to 3 years back, whether we need to include the data or not. Reason has to be suggested. Studies such as ACS suggests that the sources are having sufficient water to meet the desired water demand with extra pumping work, because this scheme has been designed with a 12 or 14 hours. If I can increase it to 16 or 17 hours, I can meet the ultimate water demand as projected. Only with the study further, only additional FHDC are required to be provided to ensure full coverage under the retrofitting scheme through extension of pipeline. This is a case study of one other state which is planning hundreds of the MBS in the scheme. In fact, thought should have given for the source sustainability of groundwater sources. Most of the MBS has been planned for the design period of 20 years. This is a major problem, which are based on the surface water, where the JJM guideline and CPHO minimum suggest the design period should be 30 years. And the service life of such water supplies is being reduced by 10 years. If some calculation has been carried out, such as only 10%, with the 10% additional cost, approximately, service life of 10 years can be extended to meet the requirement of CPHO manual. Most of MBS are based on the impounding reservoirs as source. Hence, the availability of water as source to be considered for 50 years, and reservation should be made. MBS are require huge capex and opex. Community affordability remains to be issue with the MBS system due to the high opex. We'll discuss. After completion of such MBS, state require huge budget for the repayment of the loan of the funding agency, as well as require gap funding for the O&M. So this is what we are talking. This is one of the scheme which has commissioned multi-village. Present reported OPEX is 6.5 crore. Revenue generation is less than 25% of OPEX. Present cost of production of water is 11.91 kiloliters CER. O&M not affordable. So see, only revenue generation is 25%. So I need approximately 5 crore as a gap funding in such a scheme. O&M needs to be optimized to ensure affordability. Suggestion: to ensure long-term affordable FHDC, to ensure source security, adopting dual source system. Each state should come forward with their own O&M policy, which is a state subject matter, whereas GOI is a facilitator only. This is in fact, presentation was in a brief. only to have a brainstorming, what are the problems or mistakes are being carried on state. If needed, 2 days capacity building program training can be planned, including forward training module can be developed and session can be identified by the Jal Jeevan Mission. This training should be especially for the engineers, planners, IESA who are working for the JJM program. This is the most important topic basically. Can be looked after until if my scheme is not properly planned. So functionality, ultimately what we are aiming for, the functionality of household consumption is going to be a problem. So basically, thank you. Thank you.
Thank you so much,
बंद कर दो.
Thank you, sir.
Hingorani Saab. So what we would do is we'll first thank you. It was actually very, very thought-provoking. I think it has been, you have touched upon all those very, very essential,
Yeah.
important, critical points of JJM. So I think I think these are very something which are very, very essential, where I believe every engineer who is involved in this implementation of this very important scheme should know this. So I'm very grateful. I think it was wonderful presentation, and all slides were very, very important. Thank you so much. I think it was, you have put the right balance of not being too technical and also taking care of all those important aspects. So what I'll do is we'll see first in the chat box some questions, some views have come. I will maybe this time from first, ऊपर से आइए, ऊपर से scroll from the first, yes, top से. Yeah, that is right. So नीचे नीचे अभी scroll करते रहना.
The questions.
Yes, you and me, yes, all yes. Our niche.
Sorry.
Yes. The first question is from Rajesh. He asks, solar pump based water supply is not feasible for low yield tube well, as the peak discharge of solar pump happens to be higher than the safe yield of tube well. So is this anything? So I think what we will do is next week we are planning for a session regarding this solar, solarization or related issues. So maybe I think we can cover this if at all. Hingorani Saab wants to say something about this. So
We will clarify in the next session in the solar system.
yes, that would be good.
It has been already taken care of.
Yes. Next is, can TW pumping scheme for present population of 2,500 through solar pumping is sustainable, as it will need 30 to 40 HP solar pumping. And this again is solar pumping. So we'll do our next, I think we can take up this one.
Yeah, surely.
We make this one. Same thing, I think TW pumping solar. Solar related things, I think we can.
Yeah, this is key requirement now.
Yes. Yeah, and one thing, yes, I think Dr. Mahapatra from IIPA has thanked the speaker today, Mr. Hingorani, for this one, so that's fine. Next question is from Mr. Ramesh Sama. Does consideration of future change from 55 LPCD to 75 LPCD or 100 liters is accommodated in the design, or again go for another project? How it can be done?
Yes, Sama-san, if you might have seen my presentation, there is a no ban or bar on higher water supply level put by the JJM guideline. Only restriction is that even you can go for the 150, 200. Already we are discussing task force also. But
Yes.
limitation is funding from JJM is limited to 55
55
LPC.
LPC. That is very right. That's very right. That's very right.
Yeah, only the rest of the funding is to be managed by the state government.
Yeah, next is from Mr. Rajesh, who has appreciated. He says that Hingorani sir is an experienced person in the field of water supply and sanitation. So all appreciations to you. Next is please comment on use of compressor pump in lieu of regular submersible pump for borewell in poor groundwater zones. Any comments?
Yeah, surely for planning of the groundwater supply scheme, number one should go for the summer safe field test, which is most important. I have put a word summer, number one, summer yield test, and I had to go for the considering the safe yield. Again, I had to look into that, what is the depletion rate of groundwater in that zone also. This is one of the important point. Say example, I am putting a Punjab. Depletion rate of groundwater has been reported as a 1 meter per year. 1 meter per year. If I those data, so thirdly, what is a drawdown level of the waters has been assessed, and based on the safe field, one should decide a pumping system.
Okay, right. Thank you. Next is technical manual as per JJM guideline is needed for proper designing and implementation of schemes. So I think we mostly depend on CPHEO manual.
We have prepared and circulated to the state for the comment.
Okay. So I am told that a technical manual has already been prepared by the National Jal Jeevan team, and it has been circulated to states for their comments on that. So, right, please scroll. Next is from again Sama Saab. If state has a policy of 70 LPCD, will JJM share as prescribed? Yes, I think this has already been answered. Yes. Next is from an executive engineer. He says, I have innovative technology and applied patent in 20 and applied for patent in 2010. A solution for self-regulating equitable flow regulation for WDN in new retrofitting SDS, MVS, PHED, PRI. VWHC interfacing in JJM as well as WRD, WA interfacing in piped irrigation networks, PIN, which is not based on present flow control valve. PLC SCADA is it's power free, manpower free, communication free, maintenance free, fit and forget technology. The overall offender is automatically isolated while the rest of the WDN gets its design share automatically. No human intervention is needed. The overdrawal offender's supply is automatically restored as soon as it stops overdrawal. Yes, please. Yes, our Mr. Rana wants to comment on this.
Yeah, thanks for information. In fact, just for the knowledge to every participants and all the Jal Jeevan Mission, already we have a portal on the DW website, and there's a provision for uploading all the R&D or innovative technology products solutions. And we have a technical committee which is chaired by the principal scientific advisor. So whatever the technology product solution you have, that is being evaluated and communicated to the concerned person. So we encourage that if such kind of good technology is there, kindly post on our website. Thank you.
Yeah, that's I think very, very interesting information. Yes, you can always, we have the website, you can see that login. I think, yes, you're right. And we have a dedicated section for such innovative technologies. So you can kindly share with us. Yes, please. That's good. Yes, next is. Okay, I think we can see the website. We can always share the link. Whereas CPHWO manual suggests in class 11.1.12 the need change हो गया आप scroll कर लीजिए that need to provide 100% standby above 15 MLD. Please clarify this point, sir.
See what the CPH, it is some problem with that. CPH manual clearly says water supply less than 15 mld, water less than 50 mld, we should provide a pumping system less 100% standby. More than 15 mld system should provide 50% standby. There are two water supply system having water demand of or pumping system less than 15 mld should be provided as a 100% standby. Water supply more than 15 mld should be provided 50% standby.
Okay, I think that's very well clarified. So thank you so much. How sustainability of groundwater tube well can be assessed? Do we have any technique, method to assess the sustainability of groundwater tube well? That was a question from Makul Khan Pathan.
Sir, this will be coming up in our next presentation. We have taken a very on large scale.
Okay. So next, yeah, next.
This is a really challenge to the country. So this has to be taken care of.
Okay. Again, next, a great appreciation from C North, Mr. K. Saini. Today's webinar being presented excellent by Hingorani sir. Great grip on basics and much needed at. So again, a great congratulations. Thank you for the insight from Andhra Pradesh. Excellent session by Hingorani Sahab, by Mr. Nanak Sant Dasani. Thanks for the orientation. Can I get the copy of the presentation? Was from
Surely, sir, it is available, Mr. Rana. He can post it on the website.
Yeah, thank you so much. This was from Mr. Alok Bhargav. What is the role of SCADA in JJM? Of course, SCADA is, I think it's, you know that SCADA has its own way in all rural water supply schemes. I think most of these people of the sector are aware of this.
Just to add, Kanan sir, you might have received the roadmap prepared by the technical expert committee about the sensor-based IoT system or a smart water management monitoring system. So they have clearly defined the different kind of models what can be adopted, like very basic model, intermediate model, and advanced model. So kindly refer those guidelines to go for that system. So it can be like in different stage, those things. And JGM encouraged to have those kind of system for that. Thank you.
Thank you so much for that clarification. Rana Saab, is there any government norms for recharge water? Is Dr. Umesh Desai. For recharging, is there any government norms for water recharge? I think he's talking about source recharge.
Yes. For this, we have got BIS also, Central Groundwater Guidelines also, and Mandeka guidelines also. Number of guidelines are available.
Yes. I think it's yes. Across we have a lot of information on this. Okay, so next is from again Mr. Alok Bhargav. Can I get the list of schemes being executed indicating the raw water source?
Pardon?
Can I get the list of schemes being executed indicating the raw water source?
Not clear.
Okay, maybe I think we have also given an email ID, NRC JJM. You can mail that or you can get in touch with them so this gets clarified. Next is from Mr. Manish Gangwar. In UP, we are taking 16 hours pumping hours for electricity based schemes.
No issue. We are recommended 16 to 20.
20, yes, that's that's well.
16 to 20. It is in between 16 to 20 based on the availability of power.
Right. Mr. Riaz Bhatt, sir, while designing components for a WS on a higher level, how can be the cost against 55 LPCD and the additional cost for additional service level? Acha, matlab, how can you separate that you are talking? I think he's talking about that.
On pro rata basis.
On pro rata basis. I think that's the only way out.
Oh, that's the only way out, yes.
Yes. Again, from Mr. Nanak Sant Dasani, hats off to the engineering team for the technical manual. Yes, Mr. Manoj Gupta, sir, what should be the capacity of sump if 3-4 bore wells are pumping to the OHT?
See the benchmark indicator, it should be for you can pump the water from 3 to 4 tubes to nearby overhead tank, and capacity of total water demand should be kept as a 45 to 60 minutes.
It should be 45.
It will be a common sum to
Okay.
all tubes.
Or steps. Okay. That's done. He has given an excellent points on all technical issues. Why not in revision of manual and draft OM policy may be prepared and WS Act? I think Mr. H.K. Saini is very particular on this. He said, why not revision of manual and draft OM policy may be prepared and WS Act also, Water Supply Act. Please comment.
Yeah, it is a good suggestion. Each state, this is a state subject, state has to come forward.
Yes, maybe, yes, we can, yes, think of that. They can take the services of some, experienced people like that, and then I think that can also be, can be worked out. Please send the PPT executive engineer, Jaisalmer, Rajasthan. Okay. I think we'll provide it. That shouldn't be a problem. We'll make it available. This is from Shitish Singh. Mr. Shitish Singh, respected sir, thank you so much for all this valuable information. My concern is about water will be provided to households where tap water connections are not feasible.
What he says, sir? Pardon?
He says, my concern is about those places, those households where tap water connections are not feasible. I don't know why it may not be feasible.
Yeah, it is I doubt.
Yeah, because maybe he's talking about maybe all those remote villages scattered, or maybe the topographically challenging areas and those areas, I think. So yes. Mr.
So,
He should clarify the status, then we can respond.
Yes.
So as per JGM guidelines, our objective is to provide tap connection to every rural household.
No one is left behind.
Even you might have heard the news in the cool climatic area where sub-zero temperature Ladakh and even remote area of Himachal, tap connection has been provided. So if you could just mention that what is the very specific thing you want to mention, then only we can clarify. But
Yes.
Thank you.
Thank you. I think at least, a lot of good questions are coming. People are thinking on these lines. We are very happy about this. Ruk. One is Mr. DVSWSVGR. Okay. Good afternoon, sir. Now, in this financial year, it is our state, Andhra Pradesh. We are giving FSTCs to every individual households. Now, we are asking when will we get the administrative sanction of source sustainability and storage in this financial year or next year? Please share for efficient 100% Har Ghar Jal functioning. I think this is again an issue because we have a system of giving funds to the state government, and state government in turn, distributes it to various divisions, zones. They have their own mechanism. That is to be, decided and consulted with the state government. Okay, so next is my innovative technology of gravity control tower cannot be uploaded as the website is specifically for water treatment plants. Other innovative technologies are not uploaded. Is there anything like that?
They can send the email.
Yeah, if there is, you can send us the email. We have shared you the email with along with this webinar. This is KRC-NJJ. You can yes. You can share, hyphen.
So you can see in the chat box.
Yes, you can share in that. We will try to see and we can verify it, and if required, we can upload it. Again, congratulate. Yes, at the rate go.in. Yes, correct. Geo.in, correct. Again, thanking Hingorani ji. It's very relevant, needed insights of technical requirements of designing. Lot of congratulations. Is there any criteria for 100% or 50% pumps? The next question is there any criteria for 100% or 50% pumps?
I think he's talking about the standby. So whether we should go for 50% or 100% the standby.
Now, it is very clearly, if it is a tubal scheme, it is based on the yield of the tubal. Maybe one tubal, maybe two tubal. See, total water demand divided by the yield of each tubal should meet in the given pumping hours. So, number of system in the tubal-based schemes which is governed by that, and in the multi-village water supply scheme, it is as per the water demand.
As per the
It
water.
will,
Standbys he's talking about. Standbys. Okay.
yeah, we have decided less than 15 MLD scheme, it should be 100% standby for the multi-village, and more than 15 MLD, it should be 50% standby.
Right. In
Uh,
UP,
in case in case a tubal scheme, what we suggest already it is in part of NRWP, where only one tubal is there, we can think of going for the second tubal support to
yes,
ensure the source security.
yes. Next is from Mr. Manish Gangwar. In UP, we are considering 16-hour pumping hours for electricity-based tube well schemes. Is it technically feasible to use tube well machinery like pumping plant, motor, etc. for 16 hours each day without any substantial wear and tear?
Yeah, this is no problem. We are suggesting 16 hours to 20 hours. There's no issue.
Next is from Mr. Dinesh Patil. Thanks, respected Hingorani sir. It's very relevant, needed insights of technical requirements of designing schemes. Yes, again, thanking you. Next is also Mr. Akhil Lakira is also thanking you for this, and he wants the presentation. Is there any specific guideline for SCADA and instrumentation? Is from this again from Mr. Alok Bhargava. The question is there any specific guidelines for SCADA and instrumentations?
Rana Sahab, कोई guideline बता दें.
Now, so for a SCADA side, we haven't developed the guidelines from JGM perspective. But yes, if you go for the technical best design practices, a lot of literature and guidelines available for SCADA design.
But JJM does not require SCADA personally.
So,
it has been a roadmap to the sensor-based remote monitoring system issued by the JJM guideline. JJM.
Yes. Next is from Mr. Dhirendra Kumar. Respected sir, please guide us. What should be the percentage-wise breakup of cost of components against the project capital cost and per capita cost for different types of schemes? New schemes, retrofitting, augmentation, and for solar categories, for SVS and MVS schemes in different terrains.
Practically, JJM guidelines suggest the costing norms for the retrofitting or new scheme or single scheme, but a component has been because component-wide decision will be for the site-specific requirements.
Yes, I think yes, that is very relevant because it's all there is a huge variation in the
Huge variation.
cost. We see that because of the topography, because of the type of scheme, because of various things. So I think it has to be only what we have to see is rest of the things as we talk, the design period, the quality, and rest things are taken care of, and we have to see that the cost is reasonable. I think that's the general thumb rule we have to adopt in this case. I think there is no other option because it varies. What we have seen is again an appreciation. Thanks for a wonderful session. Next, what is the extent of automation in different schemes? Different method is being proposed.
Sir, already we are repeating that Ministry has already issued a roadmap for the sensor-based remote monitoring. It is exactly what is required JJ for inbuilt water supply scheme. No other things are required here.
What is the email ID of National JJM host? I think we have shared that already. Next is one Mr. S. Mandal. What will be the procedure for FSTC in saline non-tube well zone? Saline areas, maybe he's talking about the coastal areas. Yes, proximity to the coastal areas, non-tube well zone. What will be the procedure for FSTC? Of course,
this is surface. He has to go for surface sources.
Surface sources, yes. There is no other option. Yes, obviously. Next, Mr. Satpal Rose. क्या ट्यूबवेल स्कीम के लिए जल जीवन मिशन के तहत सोलर पावर प्लांट का प्रावधान किया जा सकता है?
जी हाँ,
हाँ बिल्कुल, और हमें तो लगता है कि हम इसको ज्यादा encourage करते हैं because O&M cost and for all other reasons, and जहाँ पर remote villages हैं, power is a issue. I think we are encouraging solarization. एंड अगला जो वीक का सेमिनार होगा, मुझे लगता है कि उसके ऊपर करेंगे, सोलराइजेशन के ऊपर। अभी
Most
मैं
welcome.
सभी जो यहाँ पर सीनियर इंजीनियर्स, सीनियर इंजीनियरिंग विंग के लोग हैं, उनको मैं रिक्वेस्ट करूंगा अगले वीक, और आपका जो सबऑर्डिनेट इंजीनियर्स हैं, मे बी द एग्जीक्यूटिव असिस्टेंट, AEEs, असिस्टेंट इंजीनियर जो है, उनको भी जो है एनकरेज करिए, so that they also attend this and get sensitized about. Next week, we'll try and get someone who is specialized in solarization, solar schemes. We'll try our best. I think I have seen any clause. I haven't seen any clause related to population projection. Consideration of old population data in rural water supply schemes. Population is key role of the project. Is there any clause? Please clarify, sir, because if I take population data as such, 5 or more decades, then my forecast population will be less. I think, yes.
Yes, so as Sir has already defined, as a CPHU, we have to get the population projection. In the absence of any population data, census data, there is a provision in the guideline that for 15 years, which is called the intermediate design period, 18% population growth can be considered. And for ultimate design period, 30 years, 32% population growth. That's the thumb rule what we are recommending as per the JGM guidelines.
Okay, so thank you so much for that clarification. Next is Mr. Nitish Kaushik. Can source sustainability measures may be part of DPRs of JJM, as it will require technical expert and also funding for these works through JJM only, instead through convergence mode? I think yes, it can be, but yes, it has to be by
Yes,
convergence.
Yeah, so
Yeah,
there's
this-
a provision in the JGM guideline that when we design any scheme, groundwater recharge structure, which is one of the major component for source sustainability, that can be considered on the JGM. But apart from that, as you are aware that there are convergence fund, it's like big kind of watershed management, those kind of things. That kind of can be done with convergence.
MG Narega can be dotile.
Correct.
And I think in JJM guidelines, for tube well recharge, there is a provision.
Yes, groundwater we can.
Groundwater recharge through tube wells can be funded through JJM funds.
Correct.
Except for that, rest has to be through convergence.
Yes.
I think there are no dearth of funds for recharge, groundwater recharge and source sustainability, because we have lot of schemes which are already in operating. Only what we have to do is we have to converge and dovetail with this one. Mr. Prafulla Kumar Moharana, thanks Hingorani ji for the presentation. Please send us the presentation. Next is from Manish Dave. Thanks Hingorani sir for such information. Please share PPT. It's very useful. I think all thanking Hingorani sir for next. Mr. Chowdhury, thank you. P. Chandra, practically 1 hour distribution is being followed in Andhra Pradesh. We are designing for 8 hours due to which tail end FSTs are not getting water. Can we go for 1 hour design period?
Pardon?
The question is, this is from Mr. P. Chandra Kiran. Practically, 1 hour distribution is being followed. But in AP, we are designing for 8 hours due to which tail end FSTC are not getting water. Can we go for 1 hour design period?
No, this is not desirable practically. He has go for the detailed planned study of the distribution system and so what are the shortcomings of the distribution system, and accordingly properly computer modeling should be carried out and see what are the problems, what are the gaps with that, and he can update it and water will be available with them.
Okay, so next is thank you so much. Next is Mr. Arun Kumar. What is expected to be best criteria to decide the functionality of FSTC in villages? Quantity delivered to household or frequency of supply, that is each day or alternate days?
You go see the FSTC is defined functional definition on regular basis. What a regular basis and sustainable basis. So whatever water supply, it is a per day water supply. Daily water supply is to make part of at the rate of 55 LPCD to be ensured on daily basis, not alternate 2 days.
Just to add what Hingorani has suggested, yes, that our preference is that the regularity means everyday water supply. But what, as per the guidelines, suggests that if there is some water scarcity issue and it may not be possible to supply on the daily basis, then Gram Sabha they have to agree the frequency of water supply. But definitely there is no compromise on 55 LPCD. We have to supply 55 LPCD those things.
Yes. Yes. Right. Thank you so much. And next is from Mr. Neeraj Sharma. Respected Hingorani sir, it is generally observed that distribution pipelines are left exposed to the element, which is with an excuse that it is difficult due to topography and terrain. What is your advice in this regard?
So if you might have gone through the presentation, there are two parts. One in a hilly terrain, but there's a plains. Plains where we can easily bury the pipes. There's no issue. And hilly terrains may be exposed to the ground level etc. So under different terrains, we have to consider different type of pipe materials.
Okay, but exposed is not generally recommended, right? Exposed pipe.
Exposed is not, but in a hilly terrain, practically it is not possible. So in that case, we used to go for the metric pipes.
What pipes?
Metallic.
Metallic pipes. Okay, okay,
this
kind of
case.
GI. Sir, can we use groundwater quality till 2000 ppm TDS in TW construction, in tubewell construction?
Tubal process.
Okay.
Practically, what the WHO suggests, 1500 is okay. In the Kutch, etc., normally water supply with the 1500 TDS provided, but practically with the higher TDS, not desirable.
Okay, okay, right. Yeah, that is right. I think we have that, this one.
So
Solar. Achha, next, in which day will the webinar solar pumping scheme will be? So for the information of all, we are planning to have a webinar on every Saturday in the similar manner. So next, probably we'll inform you all. Probably the coming Saturday, we are planning to have on a solar scheme. Thank you for the interest shown. Next is Mr. T.D. Sandilya. Sir, MVS put huge OPEX. How can we minimize it?
Yes, Mr. Shandel, you will see the one case study in next presentation, next week as other peak presentation, where I put a case study where what we were discussing today, it is a MBS having the cost of OPEX of 6.5 crore, out of which 4 crore is a annual power bills. If I put a grid system to minimize 90% cost of the powers, so your system will be properly using and it will be affordable system. So with the solar system, we can reduce 90%, even more than 90% of power bills.
Yes. Okay. Next is from, thank you so much. Next is Mr. S. Mondal. Is there any guideline for maximum distance of furthest most pipeline from OHR location so that water can reach to all households? He's asking, is there any guideline for maximum distance of furthest most pipeline from OHR location so that we can reach to all households?
See, there is no limitation of maximum guideline. Only we have to ensure that in the design from the OHSR, my pressure is to be maintained 7 meter in a fag end tap connection.
Yes, yes, that is, yeah, pressure is a criteria. If it is able to meet that pressure, then there's no restriction on the distance, length of this pipeline.
Yeah.
Next is Mr. Ajay Divakar. Max limit of solar power, solar plant installation using net metering is limited to 1 megawatt. To reduce the production cost of water in MVS, this limit need to be enhanced. Kindly enlighten on the issue and its feasibility.
solar.
Yeah, we will take up this issue and in due course, If required, because these are the state conditions, if required, MNRE can be requested for the drinking water sector.
Okay, so next is from Mr. Dhirendra Kumar. For groundwater drawing, should we go for confined or unconfined aquifer in terms of water quality and water precedence?
Depend upon the requirement of water, drawal of water, past rains of water drawal. We have to decide the aquifer system.
Yes, yes, thank you for that. Next is from Mr. Chhatra Ram. Engineer Chhatra Ram. Public contribution provision should be removed in remote desert areas, JJM schemes, because of this area public depends have very low income. Acha. Okay, I think the guideline clearly says that in
Can be kind,
yes, it
liberal.
can be yes 5%, it can be 10% and 5%. 5% is we have all those remote areas, and I
Himalayan
think
states.
this one SC/ST dominated areas and all those places, and the contribution can be in terms of cash, kind, or also in terms of labor also, no?
Correct.
Anything that can be compensated. So I think guideline has provided that flexibility. The flexibility chahiye, that has been provided in the guidelines. So please bring this to the knowledge of all concerned, that it is not necessary to be in terms of monetary terms. It can be in terms of labor, kind, and whatever may be. Acha, what precautions should be taken care of while laying 63 distribution pipelines to ensure their long life?
Basically, one is the covers should be maintained more than 75 centimeter, and if required, bedding is to be given on the bottom of the pipe.
Bedding, no? Bedding on the
Pipe
yes,
bedding.
yes. Bedding, yes. The question is 1 hour design be allowed. CPHO is saying 8 hour.
Or we have answered. It has been answered.
Already been answered. Kindly provide me your mail ID at, I think, Prashant Singh. Chaliye, niche aajiye. Can UPVC pipe may be taken as pumping main?
Practically not feasible,
Not feasible,
subject
yes.
to the pressure requirement.
Yes. That's very right. Chalo, I think thank you so much all. It has been a great experience interacting with you all, and a lot of very interesting questions, lot of great participation. Still, I see a lot of people joining. Thank you so much. On behalf of National Jal Jeevan Mission, once again like to thank Shri Harish Kumar Hingorani ji, who has been very kind enough, who has been, I really appreciate anything.
Picture just one tweet.
Yes. So I am very grateful to you. So please, I would request you all to please switch on your videos. We would like to click a picture. If you don't mind, please switch on your videos. That would be nice to have you all in this. Thank you so much. So I'm very grateful to you all for joining this webinar. We will try to continue this. The basic purpose of this is to disseminate knowledge, to help all those people who are working tirelessly for implementing this mission, which is a transformational mission as we understand. So yes, kar liya? Huh? So please, yes. So I think yes, I once again thank Mr. Hingorani ji for patiently answering all those queries. Please do mail your questions and also suggestions. If you have anything to share, you please come forward. You can mail us your interest, maybe something innovative, your field experience, which has led to a substantial change, improvement in the system, maybe how the communities were mobilized, how people were involved, a system where where operation maintenance is being taken over by the villagers themselves, successful system, so that other people can learn from that. So anything related to rural water supply, we are more than glad to have your presentations. Similarly, you can have your presentations.
Someone from a state is interested.
Yes, that's what I'm saying. Anyone from the state, because I know that we are some great work is also going on in the state. So you are also most welcome to join us to have your presentations. So this webinar series will be continuing, but yes, I think this was long back going on, but again after a brief gap, this has been resumed, and I would thank Mr. Hingorani, especially because he has been the motivator for this, prompting us, please start something. So I want to share. So I think it was been very extremely helpful. I can see from the kind of enthusiasm for information. I think more than 350 people have been part of this, which is a huge number. So I think thank you once again. And again, I would request you, please, this will be, regularly we'll be having it on Saturdays. Please pass it on to your, maybe the field functionaries, seniors, juniors, who are interested, who are technically, working in the field, maybe consultants who are at lower level working. This will be very useful for them. So thank you once again for all the great enthusiasm, for your participation and support. Thank you so much once again to the speaker, Mr. Hingorani. Thank you so much.
Thank you. Thank you. So nice.
Namaskar. Namaskar.
Thank you, sir.
Thank you so much. Thank you.
Thank you.